All right, hey scholars, we are working now on our special right triangles. Now, if you were in class, we'd actually develop several patterns and see how these are being formed. But understand special right triangles, the key word are right triangles. They can only be formed and worked with for right triangles, and they're still based off of the Pythagorean theorem. Now there's two different types of special right triangles that we work with. One is called a 45-45-90, or it's also known as isosceles right triangle. And what that tells you is you should automatically know if it's an isosceles right triangle that you have two congruent legs. And when we were drawing in class, we were sitting there and we would actually ask you to go through, and we just did it really quick with like numerous ones. And I'd say, okay, here's an isosceles right triangle. If I know the leg, calculate using the Pythagorean theorem and the missing hypotenuse and other legs. So I'm like, oh yeah, the legs are the same. And we noticed if I put in just simple numbers and calculate using the Pythagorean theorem, that my hypotenuse just ended up being the leg times the square root of 2. And that is actually how we use it to write it out. So when we do this, you will simply write the triangle, and I do a visual way of doing this. Some teachers write it out just with words. But the reason why I give you this visual is it shows up on standardized tests, the SAT and PSAT, and those are huge for like scholarship competition. And it's just a different college entrance exam than the ACT. But even on the ACT, you're expected to know these. And so I would draw them out. But with this, our two legs are the same, so they're x. Now our hypotenuse is just this, the length of a leg times root 2. So I just go x root 2, x times root 2, and the x just represents what the leg is. Now some teachers write it like this, hypotenuse equals leg times root 2. It means exactly the same way, and it's a good way of solving for the sides that are missing. But this pattern works every single time. A few things I need you to remember. When you know, and I'll only give you one side by the way, when you know the leg and you're trying to go to the hypotenuse, you're always going to multiply. When you're going from the hypotenuse to the leg, you're always going to divide. Okay? So it just matters. If you're going from the smaller to the larger, you multiply. From the larger to the smaller, you divide. And here, we'd always be dividing by root 2. Another way of memorizing that is I have two congruent sides, so I have a root 2 in our figure. Now, we did the same type of thing with 30, 60, 90 triangles, and if you remembered in class, I drew one 30, 60, 90, and then we did its symmetrical one on the other side. I flipped it over in order to make an equilateral triangle, and then we just plugged in the information we knew, and then we solved for that missing side using the Pythagorean theorem. The 12 was right here. That would have been 12 root 3. Now, excuse me, 12 root 3, 6 root 3. I had wrote the wrong thing down. How helpful was that? Anyway, when you do that, it just has the same pattern every single time. But one thing I need you to remember, a 30, 60, 90 triangle has 3 different angles, so it has 3 different side legs. And so we always let the short leg be x. The long leg, which with this one, this is always short. I call this home base. Basically, if you don't know the short leg, you always find it before you do anything else. So this is our short leg. Our long leg is the short leg times root 3, so that's x root 3. And the hypotenuse is just the short leg times 2. Notice I said everything on the base of the short leg. So our hypotenuse is 2x. And that would be your hypotenuse right there. And I use that no matter what. So the key thing with this is identifying your short leg on a 30, 60, 90 triangle. So this diagram right here and this one right here, we're going to use over and over again as reference tools to decide how to solve for our missing sides. So let's do it on the first one. Now the first 4 are using our special right triangles. And, excuse me, all of them do. But the first 4 for specifically is our isosceles right. So if I was doing my homework, I would redraw my isosceles right triangle. And I would make sure I mark that my 2 legs are the same and my hypotenuse is x times the square root of 2, or leg times the square root of 2. Then when you're looking at it, you just have to ask which part's missing. Am I missing a leg or am I missing a hypotenuse? On this one, I am missing the hypotenuse. So how do I go from the leg to the hypotenuse? Well, leg to the hypotenuse, I'm going from smaller to larger, so I multiply. So what do I multiply by? What's the difference between these two? I have an x and an x root 2. I multiply by root 2. So to get to x, you're just going to go 8 times root 2. Now, doing the same type of idea for the second one. Here, I know the hypotenuse. So I want to get from the larger to the smaller. So what am I going to do? I'm going to divide by root 2. So x is going to equal 5 divided by root 2. Now, when I look at this, I can't leave it in that form because I have a radical in the denominator. So I have to rationalize my denominator, which I'm hoping all of you are getting pretty good at. So 5 root 2 over 2. And that's going to be the length of our side. And fractions are okay. Now remember, no matter how nasty the numbers are or different the numbers are, we are going to have the fact that the pattern will still stay the same on any isosceles triangle. So let's look at the next one. Okay, again, which side do I know? Do I know a leg or do I know a hypotenuse? Okay, I know the leg. So I want to get to the hypotenuse. So what do? We multiply by root 2. So x is going to be 10 root 2 times root 2. So when I do that, I get 10 times the square root of 4, which equals 20. Now, a lot of you, especially you in advance, you should be able to go 10 times root 2 times root 2 is 20. So my hypotenuse, in this case, is 20. The rule is the same. It doesn't change. All right, let's keep looking at this. As I had that totally off to the side, it must have made a whole bunch of you go nuts when it was cattywampus there. Now, again, looking at this, which part do I know? I know the hypotenuse. So what I'm going to do, multiply or divide. To get to the missing side, I'm going to divide. And what are we going to divide by? That's right, root 2. So x is going to be 16 divided by root 2. So once again, we rationalize our denominator, and we get 16 root 2 over 2. I'm done. I hope you're sitting there screaming, no you're not. Because, can I go ahead and finish simplifying my fraction here? Yes, it should be 8 root 2. Does that make sense? I hope so. Now, let's look at the next ones. Now we're going to do a lot of 30, 60, 90s. They show up actually a little bit more often, partly because of equilateral triangles, and a lot of times we use them with rhombuses and things. They're just really good ones to use because you have a variety of different side lengths. But with this one, again, I would redraw the diagram. In fact, I'm going to look for a green pen here. With this one, I'm going to make sure, there's my 30, there's my 60. I'm going to make sure I have my short leg. I'm going to mark it so I remember. Short leg is x, long leg is the short leg times root 3, and the hypotenuse is the short leg times 2. So don't forget those, and we always go home. So on this first one, you always look to see which one of the 3 sides of that triangle that you know. Well, in this case, I know the long leg. That's the long. So I want to go, no matter what, to home base. Remember, short is always home base. So I'm going to go from long to short. I divide, because longer to shorter, divide. So what do I divide by? What do I get rid of here? The root 3. So with x, I realize I just skipped the middle one here. Forgive me, we'll go back to it in a second. We'll divide by root 3. So I go 15 divided by root 3. Let's go ahead and rationalize it then. So I end up getting 15 root 3 over 3, which gives me 5 root 3. Sorry, I was working ahead a little bit, because those simplify out to be 5 and a 1. So I write that for my short leg, 5 root 3. Now, how do I get to my hypotenuse? I never go long to hypotenuse. I always go short to hypotenuse. So to get that, I just multiply the short leg by what value? Short by 2. So it's 2 times 5 root 3. So it's 10 root 3. All right, now, sorry, I skipped that middle one. Did not mean to do that, so I'm actually going to do it in a different color so we're all on the same page. Which side of that 30-60 triangle do you know? You know the hypotenuse. Well, what do I do if I know hypotenuse or long leg? You must always, always go back to the short leg. So how do I go from the hypotenuse to the short leg? Go here. Hypotenuse to short leg. Larger to smaller, I divide. What do I divide by? What do I need to get rid of? The 2. Very good. So x is just going to be 22 divided by 2, which equals 11. And the cool thing is y is very easy to get to after that, because short to long, smaller to longer, I multiply. What do I multiply by? Root 3. Hopefully that helps us out a little bit. Now, the rest of class, I actually asked you to work with a partner to see if you understood these. But I'm going to go through these fairly quickly here to see if you can understand. So, with this one, what do we do? On this one, we're going to sit there and I'm going to go from hypotenuse to short leg, because if you need to write that and go, oh, that's short, that's fine. To go from hypotenuse to short leg, I divide. What do I divide by? I divide by 2. So x is going to be 18 root 3 divided by 2. That gives me 9 root 3. Okay, so that's 9 root 3. Sometimes I think it's easier if we put it on the diagram. To get from short to long, we multiply. What do we multiply by? Root 3. So that's going to be 9 root 3 times root 3. Root 3 times root 3 is 3. 3 times 9, 27. Those should be your two values that you have. Let's look at h. Now, h, I love these. When they give you the short leg to start with, life is good. And isn't that our short leg? What's our hypotenuse going to be? Short leg times what? 2. So that's going to be 2 times 5 equals 10. How do I go to long leg? Do I go hypotenuse to long leg? I should hear a scream. No! We need to go from short to long, and to short to long you multiply by root 3. So that's going to be 5 root 3. All right, let's look at this last one here. On this last one, that's the long, but I want to get to my short leg. So that means I'm going to have to divide. What do I divide by? Well, long to short, what's the difference between here? A root 3, so I got to divide by root 3. So y is going to be 9 divided by root 3. Make sure you multiply by root 3. Multiply by root 3. That's 9 root 3 over 3. That's 3 root 3. Now, when I'm working with this, I need to go from short to long. How do I go from short to long? Well, short to hypotenuse. Didn't even think of it that way, I'm so sorry. Short to hypotenuse, what do? We multiply by 2. So x is going to be 2 times 3 root 3, which is 6 root 3. All right? Now, we're almost finished with this whole notes. And for some reason, I decided to do it all in one setting, so instead of flipping it over. So sorry about this. Long notes today. I want to find the area of each one of these. So we're going to have to use our area formulas like before, but we're going to use, instead of the Pythagorean theorem to solve for a missing part, we're going to use our isosceles right triangles. The first one is the area of this whole triangle. Now, if that's the case, we know the area formula is base times height over 2. Looking at this diagram, I would love to let this side be my base. Is there any way I can solve for that? Yeah, I can solve for it using the fact that's my height. But also, is this a 45, 45, 90? And the cool thing is I know the legs of both of these 45, 45, 90 triangles are the same. So it's 7 root 2, 7 root 2. So 7 root 2 plus 7 root 2 is equal to 14 root 2. So my base is going to be 14 root 2 times my height, which is 7 root 2, all over 2. And when you do this correctly, you should get 98 square units. Now, I know this is confusing for some of you because this is a lot of new stuff, but a lot of you are very capable of this. All right, in the next one, we're finding the area of a parallelogram. And you all know the formula for the area of the parallelogram is base times height. Well, here's your base. It's 16. My height is right here. I can't figure it out, but I can use the fact of this 30, 60, 90 triangles drawn in when I draw the height. And when I look at that 30, 60, 90 triangle, I realize I know the hypotenuse. I need to get to the short leg. My height ends up being the short leg. So I go up here and I go hypotenuse to short leg. What do? Multiply or divide from the larger to the smaller. You divide, and what do we divide by to get the x by itself? Divide by 2. So the height, show you the height here, is going to be 14 over 2, which is 7. So my height is 7. So my base is 16. My height is 7. That gives me 112 square centimeters for my area. hopefully this will give you just a quick rendition and remember when on how to do the problems, and that it will give you just that little bit of review that you need.